So welcome to day 16 on our Launch Code and Create. Today we're going to study something more specific to programming. So let's focus a little bit more on the programming aspect of JavaScript. So like we said earlier on, JavaScript is a programming language, and as a programming language, it also means we have to understand some concept of programming regardless of the language we are using. Although the examples I'm going to use here are based on JavaScript, but the concepts we are going to study are actually general to most programming languages, and they are actually proper to the programming itself. So let's get started. So in this lesson, we are going to dive into what we call control structures. Control structures. So understanding the concept of control structures will allow us to direct the flow of our programs, the flow of whatever we write as solution to most problems, most cases we will have to program using JavaScript. So control structures. So after the control structures, we are going to look at what we call functions. But before we go deep into it, I would like to also remind you of what some of the things we saw last time in the previous video. So functions. So in the previous video, we went through to understand what JavaScript is and various ways of having JavaScript written either through the syntax or depending on the environment. And we also went on to discuss a bit of things related to JavaScript. We mentioned particularly the variables. So the variables, and if you read the course on launchcourse.com, I added some examples of how to declare variables. So we mentioned that we use the keywords let, like we saw in our example, the keyword var, and then the keyword const to create variables in JavaScript. And I said variables are actually references to values in the memory of the computer, or in the memories of our computer. So const. So it means if I have a variable a which references a value 3 in the memory, so we are going to have let a, and then we put the equals to sign, and then we write the number 3 in there. So that's how we declare variable. So apart from that, we also discussed what we call the operators. So if we had another variable, let's say b, so let's say b, and then we assign 2 to b, then and we decide to do a plus b, then we are using what we call an operator to make this operation happen. And probably we are also going to have another variable here, which is let, probably s, which is the sum, and we'll use the equals to operator as well to assign the value of the operation to the variable s. So these are the things we have to understand very well. So we also discussed another aspect of JavaScript, which is the types of data. So like I mentioned in that lesson, we might have a number like this, which is an integer. We could also have a number like 3.2 or 0.5, which is a decimal. But in JavaScript, either decimal or integer, they are all same numbers. But apart from that, we could also have, so we have here types. So types. So apart from numbers, we also have other types in JavaScript. So let me mention numbers. So you check on the website, you say I gave a list of them there. So apart from numbers, we can also have what we call strings, and that's what I really want you to get here before we move on to today's topic. So we have strings, and strings are actually sentences, words, or characters. So like what you have in the alphabet. So, but it can be also a group of numbers. But what makes something a string for JavaScript what will make JavaScript to consider something as a string is when it is in between either single quote or it is in between double quote, or it is in between what we call the backtick. This is one of the keys on your keyboard, which is a backtick. So if you put anything within these characters, JavaScript assumes it is a string. So if you have a variable, for example, let name be equals to, and then we put Ali. So the Ali actually here is what we call a string. So this variable actually references a string value and so on. So it might also happen, and we have something we call concatenation. So go ahead, we add concatenation. The concatenation concept is the idea that concatenation, if you have a string or you have a particular variable type, you might join it with a different variable type. So what it means, if we were having this let a equals to 3, and let's say this is a number of apples we have, so we would like to say I have the number of apples we have is, and then we actually allow JavaScript to display the value of a. So that can happen. Concatenation. So we would like to write, okay, we have, let me use a different color. We have, let's say, 3 apples, and but we know that the value of 3 is referenced by the variable a. So we wish we could write that a here and allow JavaScript to automatically guess that the value of a is 3, and then in the result we just get, we have 3 apples, right? Apples. So we need to get a way for JavaScript to interpret this as the 3 instead of just writing the a. So this kind of things is what brings us to this challenge of how do we combine this string with this variable and then this string. So these are strings. So the way we do it is we put the strings in the quotes, be it in single, double quote, or backtick. Of course, there are different ways of handling this situation, whether we are using single or double quote or backtick, especially the backtick. There's something special about it, but for now we'll focus on this basic concept. Then we put the plus sign in between. Then we put the plus sign in between here as well, because this place is also a string. So as far as the two different types join, we should always use a plus sign, which is the concatenation operator, to create the joint relationship between the two data types. So this is basically what I want you to have ahead before we go we move on to the actual subject of today, which is control structures. So like I said earlier, control structures allow us to control the flow or the direction in which our program runs. So the reason being this, so when you have this problem, like we had a problem earlier in our previous video where we mentioned an example of mom bringing us mangoes. So, and we don't know how many mangoes mom brought. So we could actually determine them by removing the actual total mangoes we have, by removing the mangoes we had from the actual total mangoes we have right now. So, and we could add some conditions. So that's if mom came after putting the mangoes in the fridge, she ate some, and we know how many she ate, or maybe we don't know. So we can ask if mom ate 2, then by now we might be having a certain number left, or else then we should have the exact number of mangoes left. Nothing would change. So you see, based on some situations, we might want to think in one angle, and then if the situation is accomplished, the program does one thing, and if the condition or the situation does not happen, then the program goes the other way. So, and I've also mentioned the case of we have in this slide. So for example, if you have a slider on your website like this, and then you have these two arrows, and in here you have pictures that must flow. So anytime the people click on these arrows, it must actually define, it might make the banner flow either in one direction or the other direction. So let's say if you click on this button, so then you make it green, it will go in this direction. And if you click on the left button, then the banner should scroll at the left side. So in these situations, you might want to know, did the user click on the left or on the right? So you would probably say, so in this case, we use what we call the if statement. So you bring the keyword if like this, then in bracket, you write now the statement, the condition. So let's assume we are checking a click direction. So we name it click direction. So we assume that click direction contains what where the user actually, what the click the user did, whether on this or that, and we have a way of checking it. So if the click direction, and we use what we call double operator to compare, this is a comparison operator, is different from the assignment operator. This one is take the value of the uh, reference this through this name, and this one is like whatever is at the left, is it the same as whatever is at the right? So that's a comparison operator. It's simply like the way we do in math to say, is this the same as this? So is it here? So if the click direction is left, for example, which is another variable, then we do something. So we do something. We move the banner left. So let's say we do left, right? So that's how we check something. Or you could say if the person's age, so in this case we use age, if your age is less than, or let's say your age is greater than, let's say 35, then we know that you are an adult. So you are adult. We do the stuff of the adults here. Adult. Right? And then we close it. But it might also happen that we have cases where not only we want to know the condition, but we also want to know the opposite of the condition. So if your age is greater than 35, what else happens? So we can also continue checking by saying else if again, the age is less than 35, then you belong to a different category of youth. So you are a young person anyhow, so you belong to a different category. So if that does not happen, probably your age is still oh, I think this I could say, okay, I already said greater than here, so let's say that. So else we could say again, we close this condition. So if it happens that no, your age is not less than that, it is greater than this and it's greater than 35, so probably you are too old. So because what this means is that your age is not less than 35, but it is also greater than 35. So it means you are in a different category. So this is just an example. I'm not really doing this well in this example, but this is to make you understand the concept that we check different states, we check different conditions. So we call this the if statement, and we call this the else if statement, and we call this the else statement. You don't always have to bring the else statement or the the else if statement. So if your condition you are checking is just one thing you want to know, it is fine. But if the conditions are tied, then you might need to use else if statement, because what this means is only one of these conditions will be executed. one of these blocks will be executed. So this else if statement is usually useful when you are, for example, based on a student's scores, you are determining the grades they are having. So we know that if we have a variable called, we say let score, let's say the score is 85, so we do equals to 85. So we can check, for example, if the score, so if score is greater than or it is equals to, so you see this operator here. So if the score is greater than or equals to, let's say 90, right, that's the condition. Then in the block, what would happen if that is the case? So here we can tell the person that your grade is A, for example, and we'll close this block. So if the score is not greater than or equals to 90, it must be something else. And we also have to verify that, because we cannot simply say another if again, because if you say if and you check that the score is less than, or the score is greater than or equals to, let's say 80, then these two conditions will be executed. So for us to tie them, to make sure that if this one does not go, you go to the next condition, and then if that one does not go to the next condition. So we chain the conditions to make sure that one out of these conditions will actually be executed. So we can add else if in bracket, if the score again is greater than or equals to 80, in this case, let me make it 80. So in this case, the grade can be a B grade. So we are not done. So we can check again until we get like the condition where the person has C. So if that's the last condition, so we can say else. So in case all these fail, else, in case all these fail, then the score is C. And then we end it there. So this can go very long and tough depending on how tough the conditions are. And like as I mentioned with the example of the banner here, these problems don't always have to be basically like our daily arithmetic issues. This arithmetic can be like you are probably calculating the dimensions of the screen. So it can be, let's say, if you are, scrolling a web page, but from top to the bottom or vice versa, so you are scrolling it vertically, you can decide to know, okay, at which stage are you? Have you scrolled up to half of the screen, or have you reached a quarter of the screen, and so on? Have you reached the bottom? For example, when you are browsing on some websites, when you are scrolling, you get completely down, you see an arrow appear right here, asking you to click and jump back to the top of the page, because they don't want you to be scrolling step by step, one by one. So they actually ask you click here. So it means in this situation, there must be some JavaScript that detects the scroll level. So how far have you scrolled? And if you scroll to the bottom of the screen, which is a distance basically, so which is the position in pixels of your web page, and then find out, okay, if this position has reached a certain threshold, then we can bring this button out and then allow the user to click and jump. So these values, these calculations don't always have to look like age or so. It can be anything. So that's what I actually mentioned earlier in the previous lesson. This is programming. It's about thinking. These are tools to make you think, and whatever you think about does not matter actually. But it is a tool that can be used in any direction. So you decide what to do with it basically. So the next thing we can look at is what we call a switch case. A switch case is when you have a lot of if statements that happen like this and it becomes very tall, then you can switch to what we call a switch case. It is a bit cleaner and simpler to manage. So how it works is that you give it the keyword switch, Then in the switch bracket, we put in the condition we want to know, or the element we are testing against different cases. So let's say we have a variable day. Let's say we have a variable called day, and that variable, so we do let variable day has the value of, let's say, 1 or 3. So we can assume here I'm setting these variables values manually, but it could be an input from a user using our interfaces. So in here we place the variable day, and now we decide to check various cases. So the first case we want to check is we use the keyword case. We write the keyword case, and then you write the value of the case. So let's say it is 1. So what we are saying is that if there is day, the value inside the variable day is equals to 1, then you bring colon, and then if that is the case, if these two tally, so the value inside day is the same as the value in the first case, what should we do? So we do whatever we want to do. The condition is satisfied, we do the doing, and then you bring the keyword break. Bring the keyword break. What this means is, okay, leave this case and move on to the next case. Don't pass through the other cases again. If there are any other cases at the bottom or above you, don't check these cases again. Leave the whole switch and move on. So we add another case, for example, and that case is going to be 2. So, and we are trying to say, so the second case is the variable day referencing a value which is 2. If that's the case, we do the do. So we do whatever we want to do here, and then we also bring break. And then we move on, and then you can add as many cases as possible until you meet the actual case. And in our case now, you can see that this is the third case that will actually be satisfied. So we do this here. So this is the one that matches. So once you are done, you can use another case called by default. There's a case called default. So that's in any of these cases. If any of these cases does not work, then we can use whatever is in the default block. And so we also do the break. Then we can now close the switch. So the switch started. Let's use this. So the switch started here and ends here. And inside it, we have so many cases. Or actually 3 cases. Yes, excluding the default case. So what we are trying to say is, okay, is day the same as 1? If so, we do whatever is here. Is day the same as 2? If so, we do whatever is here, and so on. And in all the situations, in all the cases, only one of the cases that will pass through. So this can be very important, and you can see how clean this looks compared to the if-else statement and else-if statements. The else ifs and the ifs and else ifs can become cumbersome when the conditions are many. So in these situations, always remember to switch to a switch. But it doesn't really matter which one you use, and your condition, your situation, and your context will determine what fits best actually. So that being said, let's move on to the next point of this video, which is about functions. So functions. What are functions? Functions are very important in any programming language, even in mathematics. So although I use math examples, some of you might not be familiar with mathematics, but the idea is a function is a box. And what I used to use as a real example is the corn mill, right, that has this stuff here that can collect some food stuff, let's say corn or maize and so on, and then it goes through this particular engine which has an ending like this. So and it goes like this. So you put in the corn, and then the engine does some work through some other wheels that turn, and so on. And then in the output, you get a powder, probably in a pan like this. So you get a lot of powder inside. So that's how I interpret functions. So there's this, if you see this corn mill, there's this particular stuff here, a gear that you can use to change the direction. You can actually tighten it or loosen it. That's what it does. So by tightening it, you make the powder come very smooth, and if you loosen it, the powder is less smooth. So you kind of control how this whole process works, and that's what functions are all about. They take something, and then based on some conditions, some settings, and they bring something outside, something relatively different. And the reason I'm saying relatively different is because one, it requires that something goes in, or if there's nothing, it is still something, because if you put empty, we will get empty, or we'll invent something because you brought empty. So definitely the output has a relationship with the input. So that relationship is what I mean by relatively connected, right? So if we put, let's say in our case, we put a number a, which has a variable a, which has the value of 5, and then in our engine here, we set it to do, if we turn it in the clockwise, then it is going to times the number by 2. And then if we turn it to the counterclock, it is going to do -2. That's our condition. So it means in the pan here, we are going to get, if we turn it clockwise, we are going to get 10. And if you turn it against the clock, we are going to get 3. So basically, whatever you put in, and based on the conditions and the settings inside, the output will be brought out, either in the way you expect it or in the opposite. So in reality, how do we make functions in JavaScript? So initially, you can use the keyword function. So you write the keyword function. Just like the corn mill has a name, your function too needs to have a name. So let's say this function we have is, it will do times. So what I mean by that is that the only thing this function does, or this our corn mill here does, is to times whatever we give it. So let's say we give it some x value. So anything you enter, anytime you use that function, it will return. So we use the keyword return to say what it should bring out. So it will return x, like we said, times 2. Notice how I'm using times. Times in programming, or in most programming language, is asterisk, not the cross. So here is the cross which represents x, but this is asterisk to say multiplication. So anything we give to this function, it will return it times 2. So look at the syntax of writing the function. It starts with the keyword function, then a name, then what we call its parameters. So the parameters are optional, so you can have functions without any parameter here. In that case, you just get empty bracket. And now the operations it is going to make, and these operations correspond exactly to what this engine here does. So based on the settings, it will do that. Our setting here is that times it by 2. So in the machine case is you turn the wheel here clockwise. So we can have other functions. So we have also different ways of creating functions. JavaScript being so generous, it thought, okay, this is cool, it works, it's fine, but we could also decide to declare a variable. Let's say we create a variable var. We use the keyword var here, and we name our variable add. So this looks like a variable that needs to add something. Then to the variable, instead of us to assign to it a straightforward value, we can now assign to it a function declaration. So we use the keyword function, and then it can also take parameters and do some stuff and return some value. and we close the function. So you say looks like you moved the name of the function out there and then just change it into a variable, and then you put the equals to sign, and now you bring the keyword function out at the other side, and that's how you declare a function. So these kind of functions are called expression functions, and what we have here is a declaration function. So as if that wasn't enough, JavaScript also offers another option, what we call the arrow functions. So in that case, you could write a variable like this. So we use the same function add. So we bring add. So and we say it's equals to, and then all you have to bring is the bracket. So now it's like we get rid of this keyword function. And now instead of us to use square brackets, curly brackets like this, we don't do that. We use what we call a fat arrow, and we do like this. Then now we can bring the curly brackets, or if you want to, we can ignore them if you are just returning one thing. So this is quite that's a number of ways of actually having functions declared in JavaScript. For now, this should be enough to help you understand your JavaScript. So with these basic elements, starting from the variables, right, the operators, control structure, starting from the variables, as we said, the operators, a bit of data types we've seen, and how to handle control structures and how they help us to shape the flow in which our programs run, and using functions to scope some features. So for example, if you have an operation that does the multiplication of the numbers by 2, then you can move that into a function. And we have 3 different ways of using or creating functions. So the next thing we might look at is how to use the function. So to use a function, basically in JavaScript, you just have to write the name without the var in front. So in our case, for example, add. So and then you put bracket. So if the function in its declaration was having parameters, you have to assign this parameter. You have to provide these parameters. So in our case of a times function, for example, if you call that function, we say times like this, and we have to put in a value which is 2, for example 3, and then that means if you put in 2, it is going to take 2 times 2 and return 4, and so on. And we could also have functions that have more than one parameter, so it might be xy. So if it is xy and none of the parameters are optional, so we also have to come and provide some value here. So basically that's all you need to know for now. And in our next lesson, we are going to explore another concept in JavaScript language called the objects and so on. So I hope you stay around. Kindly like our videos, subscribe to the YouTube channel for more videos on your way.